Okay, so welcome to our immunology class for spring 2021. I hope all of you are having a good first day of classes this semester and that you're getting off to a good start. I'm really looking forward to having another semester of teaching immunology, although I'm sure I share the sentiment with you that it would have been nice if we were all back to in-person classes by now. But I think you're all aware that that just wasn't going to happen. But soon, hopefully, the light at the end of the tunnel. So hopefully this spring semester will be the last one when we have to worry about doing everything online. So let me introduce myself. I'm Howard Shen. I'm your instructor for the class. So this is Micro 461. And on the screen here is my contact info. So feel free to email me if you ever have any concerns about content, material that you're having trouble with, or if you would like to meet for office hours. So my office is in the Life Sciences Building, room 311, and my office hours are by appointment. Either in person or over Zoom is fine by me. If you would like to come in and sit down and talk with me, I welcome it. I think it's a wonderful way for me to get to know my students in the class, especially with everything being online. But if it's more convenient, or if you prefer just to have a one-on-one conversation over Zoom, that's totally fine with me as well. All right. So even though I don't have standing office hours, because I kind of discovered last semester that if I have standing office hours over Zoom, it's just usually me sitting here with Zoom open and I'm just like doing nothing for an hour and nobody shows up. Right. So it's way better just to go ahead and if you want to talk with me, just make an appointment. Send me an email and I will respond to you. Again, because of the size of the class, I ask that when you log into lecture, you please keep your cameras turned off and also mute your audio so that it's not distracting to your classmates who are trying to pay attention, and not distracting to me because I lose my train of thought very easily and you'll send me off on some weird tangent somewhere. Okay, so really quickly on Laulima, we have the course syllabus, which is available under the Laulima syllabus tool, and that provides all the information about things like grading and different things about makeup, if you have to make up a quiz. It talks about how the different parts of the class contribute to your overall grade. So take a look at that. And very importantly, there is a note about the technology requirements. So it's really important that you have a suitable laptop or iPad to be able to attend lecture. Now, I do record these lectures and I post them on YouTube. So you will see the link to our YouTube channel in Laulima. It's provided there. And just a real quick word about the technology requirements. You are required to have a suitable device like a laptop or a tablet when you can log on and take the exams. The exams are given at specific times, class time, and they're delivered, during that time live. So you need to make sure to be able to log in with Laulima and take that exam at the appropriate time. We'll talk more about that as we get closer to the first midterm exam, but I just wanted to give you a heads up to make sure that all of you have a way of being able to log into Laulima and take a test that's being delivered, at a specific time. Okay. For those of you who don't have a suitable laptop or computer, maybe you're hoping to just sort of watch this over your phone. I really try to encourage you to come up with a better way of doing Laulima rather than over your phone. Okay. Maybe borrow a laptop or a tablet from somebody on those exam days, or come to campus. That's another option. Make use of the computer facilities here in the libraries and the computer labs, or even contact the School of Life Sciences office, because I know for a fact that we do have loaner laptops that are being lent out for students who need it for the semester. Okay. So in addition, there is a schedule file on La Lima as well, and that gives you all of the list of dates for when we have exams. Um, in this class, we have pretty much every week an online La Lima quiz. So it's a short, like 10-question timed quiz for 20 minutes that it's up to you when to start it. So you can do it at any time you want, but they are always due Thursday night by 11:55 p.m. So that's one way of making sure that everybody's taken the quiz and we can move on to the next set of topics so that we don't end up falling behind. So those reminders of which quizzes, which dates have quizzes are on this lecture file as well. The schedule in addition to pointing out when the different exam dates are. Okay, so take a look at the syllabus and the schedule first, because chances are that'll answer any questions you have about how the class is going to be run. If you have other questions, feel free to go ahead and email me. Okay. So here we are again with another online semester, and I think with the beginning of every semester, I think everybody's anxious, whether it's normal in person or online. And then when you wake up Monday morning, you know, you're just thinking about things like, oh, how are my classes going to be? How is it going to work this time around? I hope my professors are nice, right? I hope my professors aren't jerks. And I hope that I can get through the semester successfully. I think one of the very last things you think about when you woke up this morning is whether or not your immune system is working well. Of course, these days, I think our immune system is maybe more at the forefront of our minds and we're more aware of our immune system than, you know, in years past because of the COVID pandemic. But I still think that on a day-to-day basis, when you're waking up this morning, getting ready for class, you know, your alarm clock goes off, you brush your teeth. Instead of coming to campus, a lot of you now can just kind of roll out of bed and just get on your laptop in time for class. I hope you're still brushing your teeth though, right? Or at least putting on some clothes, right? And you don't think about your immune system. We tend to think of our immune system only when something goes wrong and we start feeling sick. Then we are very quick to like blame our immune system. We think like, oh, I have a lousy immune system. I'm catching a cold or the flu. Or right now you think about the people who are catching COVID, right? And you think to yourself, those people's immune systems, they've been compromised, right? And I hope that my immune system doesn't have to deal with something like that. But we don't actually think about the fact that our immune system is always working 24 hours a day, 7 days a week, our entire life from the time that you were born. You've had a robust and functioning immune system that you really don't think about, except for those occasions when you feel sick. Right? But microbes are all around us on all the surfaces, whether you're talking about coming to campus, sitting in a classroom, on a bus, or even at home, right? You are surrounded by microbes. And that's not something that we usually think about. Okay. So hopefully, as we begin to talk about our immune system, this awareness of our immune system and what it does for us every single moment of our lives will be something that you will learn how to appreciate a bit more, and hopefully it'll interest you. What is immunology? Right? The simplest definition of immunology is that it's the study of how our bodies cope with exposures to external, pathogenic, parasitic, or other perceived antigenic threats, as well as internal threats that are coming from within us, brought on by disease. Now, when I say antigenic threats, that is a term that I think many of you might have, you know, some kind of feeling for what we mean when we say an antigen. But we will explore that a lot more, that definition of what an antigen is and why it's very important for understanding what an antigen is as part of understanding how our immune system works. So the whole study of immunology then encompasses, right, knowledge that's very broad. It ranges everywhere from maybe just understanding the molecular cell biology that's involved with immunology, all the way to a much more macro scale of understanding dynamics of diseases and how diseases spread in human population, right? Immunology kind of is an umbrella that covers all of these things. Here are some nice images from the textbook. And I do want to mention that the textbook that we use, The Immune System by Peter Parham, I'm sure some of you are wondering, do I really need to have that textbook? The textbook, I think, is a very useful supplementary part of this course. The majority of this course focuses on just the lecture material that I present to you, but my lectures and most of the content in the lectures do follow how the chapters of the textbook are laid out. And most of the illustrations that I use in my slides do come from the textbook. Okay. So I know some of you will ask me, do I have to spend money and get this textbook? Because I know, many of you, just like myself, when I was a college student, I'd spend all this money on textbooks, and some of them I'd never even open, right? And then I bought it for like $150 or something, didn't use it, and then I would go to sell it back to the bookstore, and they offer me $15 for it or something, right? I cannot tell you that, yes, you have to buy the textbook, all right? Because different students study differently, and different students may benefit differently from having the textbook to refer to. I encourage you, if you're on the fence, you can buy the ebook version. It's a lot more affordable. Or even though I don't condone this, I bet you if you're pretty good at doing Google searches, you can find a copy of a PDF of the textbook online. All right, although you didn't hear that from me, right? The textbook will help you when there are times when the lecture material, maybe you need a little extra reading to clarify, then you can go to the textbook. Here are some illustrations from the textbook. It is actually a really nice textbook. But one thing I want to point out to you is the immunology textbook that we use, right, is not meant to be, immunology for undergraduates, right? It's not like that. It is just immunology. And that means the author wrote it with a whole range of different people in mind, including graduate students, medical students, even maybe physicians who have been practicing medicine for many years and just want something to refer to kind of brush up and remember certain things. As a result, there's a lot of stuff in the textbook that we don't actually touch upon in this class. Okay, because this class is meant to be an introduction to immunology. It's meant to cover a lot of stuff, but really hit upon the most important concepts that I think will set you guys up very well with a foundation of understanding immunology that you can build upon if you do go to graduate school or medical school. Importantly, I know many of you are thinking about taking the MCAT, and I do think that this course does address many of the types of topics that you could expect to see on an MCAT type of exam. So here are some colorful photos from the textbook. These are just examples of different types of pathogens, right? And there's a wide variety of pathogens. They can be single cell pathogens, for example, like this bacteria here, these bacteria here. They can be prokaryotic or eukaryotic. They can be things that are multicellular, like this worm that's made up of potentially thousands of cells, not just a single cell. And pathogens might not even technically even be a living thing. Right? So over here are examples of viruses. Like the coronavirus, a virus, it's questionable as to whether or not you'd really consider a virus actually a living thing. So how do we define a pathogen then? So here's a functional definition. We can think of a pathogen as a biological entity that has the potential to invade and colonize the human body, thereby causing disease. Again, it might be a single cell, it might be multicellular, or in the case of a virus particle, you can think of a virus particle as nothing more than just a collection of biological material that's packaged up in a certain way that it can, in fact, invade and spread. There are four main categories of pathogens that we will discuss this semester. And those can be broken down into bacteria, such as salmonella, if you think about food poisoning, right? Oftentimes salmonella on undercooked chicken or some spoiled eggs, right? Viruses like hepatitis or like the SARS-CoV-2, different types of fungus. So fungi, like the types of fungi that cause athlete's foot, right? That itchy, burning kind of a feeling between the toes, right? And the fourth group would be parasites. So these tend to be, when we think of parasites, we oftentimes think of multicellular organisms like, for example, a rat lungworm, which you might recall is kind of a big deal when you're talking about produce like lettuce that is not washed properly, and you might actually have the eggs of things like rat lungworm on them. So if these diverse, different entities, right? I call them entities because, again, viruses, it's questionable whether or not you'd really call it a life form. Right? If we have these diverse entities and they're all pathogens, what do they have in common that we can use as sort of a defining trait that something must have in order to really be considered a pathogen? Bacteria, virus, fungi, or worms like parasites, they all have in common this defining trait. They all contain a genome, right? So that is a important kind of first definition for you to keep in mind. Something is really a pathogen if it has genetic material that it is following instructions to carry out. Right? That's why some things that might irritate your immune system, for example, right, like dust can irritate your immune system, different types of things like allergens, like oils, like peanut oil, right, can cause strong immune responses, or even things like smoke from tobacco can cause immune responses, right? But those are not really pathogens. Right? Those you can almost think of as more like irritants, right? Because those things don't have a genome. Their purpose is not to colonize and start taking over, right? Those things are just irritating, right? So the difference is a pathogen is something that actually wants to colonize and make its home in the body. So pathogens exist in environments. We already mentioned that even something around your house, there's many different environments where pathogens can exist. So here are just some examples of different types of environments that we might encounter pathogens in our day-to-day normal lives, right? Whether it's being in a busy urban setting, in a classroom lecture, at a party, right? Or going on a nature hike, hanging out at the beach. Here, this couple, they're hanging out at Lanikai, right? Or places like an airplane, right? A stinky airplane. Right? Certainly we worry about things like pathogens there. But even if we're doing things like playing sports or at home just minding our business, brushing our teeth in the bathroom, right? There are pathogens around us. And yes, of course, in places like hospitals, there are pathogens as well. So here are this panel of a dozen or so different environments, but there's one environment that's common to all of these images here. And that is perhaps the most important environment for us to think about when we are talking about our immune system. Right? Give you a moment and you think about it. What environment is actually pictured on all of these that is fundamentally the most important environment for us to worry about when it comes to studying immunology? Okay, I think most of you have probably figured out what I'm getting at is the human body itself. Right? The human body is a self-contained environment. Right? It's kind of funny. We think of it as an environment. Well, we don't think of it as an environment. We think of ourselves as just going to different environments every single day, right? But we don't think about the fact that we ourselves are an environment in which different pathogens would absolutely love to colonize and be part of. So the body is, in reality, an ideal environment for many types of microbes. As an example, just to get you thinking about this, There are about 1,000 different microbial species that live in our gut. The number of different microbes, individual microbe organisms in our body at any given time dramatically outnumber the number of our body's own cells, about 10 to 1. Now, what do I mean by that when I say it outnumbers our body cells 10 to 1? What I'm saying is, if you were to imagine, for example, here I am, lecturing you, right? If I were to be able to take apart my body cell by cell, all right, everything that you see in front of you here, right? I'd say, oh, this is a human cell. I'll put it in this pile. Or, oh, this is a microbe, like a bacteria, for example. I'll put it in this pile over here. By the time I've completely disassembled everything you see in front of you, right, the microbe pile would outnumber the human cell pile 10 to 1. It doesn't mean the microbe pile would be bigger, right? Because the reality is each microbe is teeny tiny compared to a typical human cell. But in sheer numbers, right, there's more to me here in terms of being microbes than there is human cells. Okay. So we carry, for example, around 5 pounds of bacteria as part of our body. We lug it around with us every day and we don't think about that. You're like, what? That's disgusting. But it's true, right? On our skin and in our gut are tremendous numbers of bacteria, 5 pounds, right? Most of this bacteria is considered what we call commensal bacteria, or good bacteria, good microbes that exist as part of our normal body's function. So the term commensal, I think it comes from Latin, and it means eating from the same plate. Okay. And indeed, that's what it refers to, the fact that you carry around a lot of bacteria in you that are making use of the nutrients that you're eating. Right? You eat food, and the bacteria in your gut benefit from it. Right? So what's the difference then between a good bacteria or a bad bacteria? Or let's say a good versus bad bug? The reality is they're usually just different strains of the same species of an organism. E. coli is a very well-recognized bacteria. When I say E. coli, and if I were to ask you, is E. coli good or bad? I think most of you and the general public would say, oh yeah, E. coli is bad, right? Because you hear about E. coli poisoning. But the reality is different strains of E. coli are very far from being bad. Many of those strains are actually vital for the normal functioning of our gut. An example in green here is this E. coli, this particular strain MG1655, which is considered a good E. coli. So this is a normal commensal bacteria that you have a lot of in your intestines. This E. coli actually helps you digest your food. And in the process, it produces some vitamins that our own body cannot produce by ourselves. And therefore, we've evolved to expect that you'd have bacteria in your gut making certain types of vitamins that are then absorbed by our body and put to good use. Another important function of good bacteria is that the populations of good bacteria keep the populations of bad bacteria in check, right? Because all those microbes are competing for the same pool of resources, like the food that you're eating, right? So the more good bacteria you have, it helps keep the bad bacteria at bay. Now, when I say bad bacteria, what am I talking about? Here's another strain of E. coli. This one is known as O157H7, and this is a particularly nasty bad one. This is the bacteria, the E. coli, that you think of when you think about food poisoning. In the past, when you've had outbreaks of food poisoning from like fast food chains, for example, back in the 1990s, there was a big outbreak of food poisoning from Jack in the Box. There were thousands of people who got sick from it, and several people actually died as a result of undercooked hamburger patties. And that was due to this strain of bacteria. This E. coli secretes certain types of proteins that are toxic, in particular this Shiga toxin that's named after the researcher who discovered it. And this Shiga toxin, when it gets absorbed by the cells of your body, like the cells that line your intestinal tract, it actually blocks those cells from properly doing protein synthesis. And if you've taken cell biology, which I hope you have, you know that the ability of cells to produce proteins, right, is a vital, essential part of a cell staying alive. Okay? So as a result, um, infection with this bad E. coli leads to the intestinal walls breaking down because the cells in the intestinal walls start dying, and you get a lot of bleeding and a lot of loss of ability to maintain proper things like water management in your gut. You get severe diarrhea, and typically, we have something like 75,000 cases of E. coli poisoning from this particularly bad E. coli every year in the US. And typically, we have something like 90 people or so who die every year from this. So these are both E. coli, though. They are the same species, right? Escherichia coli. And yet we say there's two different strains, and they can have a dramatically different influence on our health. So why is that, right? How does that work? I'd like you to think about commensal organisms that are right now in your gut, right? And make no mistake about it, right? Whether or not you realize it or not, there's a whole bunch of commensal microbes that are part of you right now in your gut, helping you digest your breakfast, helping you get nutrients out of the food from last night. Right? Commensal organisms have to coexist in a balance, and that's what keeps us healthy. If you think about something like the family dog as an example, I don't know if you realize this, but technically speaking, there is only one species of domesticated dog, and that is this Canis familiaris. So all domesticated dogs are Canis familiaris, but many dog breeds exist, right? Obviously, many dog breeds exist, right? Everything from small dogs, big dogs, poodles, chihuahuas, Labradors, Rottweiler, right? These are all different breeds. So these can be thought of as different strains of the same species. If you have multiple dogs living in the same household, like in this picture here, all of them, right, have to share the same resources that are provided by the family, and competition between them is in balance, right? They happily coexist. Problems come about if that balance is disrupted. For example, the owners bring home a dog from the pound, right, who is really aggressive, right, very hostile to the other dogs, and starts outcompeting the other dogs in the family. As a result, there's a dramatic change in the dynamics of the household. Hopefully it's not so bad that the owners have to take the dog back or something like that. But that's what we're getting at here. You can have many types of similar microbes, many types of, for example, E. coli bacteria that exist in your gut, but they're in balance, and that helps keep problems from forming. But if a bad microbe comes along, right, that can throw things out of whack. So in the case of, let's say, the microbes in your gut, here's a cartoon that depicts the shifting of that balance leading to disease. So the colon is colonized by large numbers of commensal bacteria. So this gray thing here represents the cells that line the tract of your colon, your large intestines. Okay. The lining of our GI tract in many places is very thin and very delicate, oftentimes not more than just one cell thick. And it's designed that way because you have to think about what is the function of the lining of your gut. It is to allow certain things like nutrients to be easily absorbed, right? And so there's got to be a very thin layer that separates the space inside of your gut with the tissue that's surrounding it. So that's why in this illustration here, you can see that this is the individual single cell wall thick barrier between the lumen of your gut. So the lumen is when you have an organ in your body that has different types of chambers or vessels that flow through it. The lumen is the space inside those vessels or chambers, right? So in the case of your intestines, this would be the space that all the food that you've eaten is passing through. And it is the space in which all the commensal bacteria live. So these purple bacteria here are commensal gut lumen, right? On the other side of the wall of your colon is the tissues of your body, right? So normally the bacteria are kept from getting into the tissues of your body by the wall of your intestines. If this balance is thrown out of whack, for example, if you end up eating a lot of bad salmonella um, bacteria, right, as part of undercooked chicken, right, then suddenly you have a lot more bad bacteria in your gut that starts doing bad things. Or this can just happen if you take certain antibiotics. Antibiotics kill bacteria. If you take oral antibiotics that are meant to go to work through your GI tract, the antibiotics oftentimes don't discriminate between good versus bad, right? It just kills all bacteria. So you can see if you took antibiotics, many of these commensal bacteria can in fact be killed also. And that allows then for the pathogenic bacteria, the red ones here, to be able to start getting a foothold and start dividing and taking over. So if this were the bacteria like the bad E. coli that secrete Shiga toxins, maybe that's what these little red dots are, you can see that damages the wall of your intestines. And then you have a breach, right? You have a break in that barrier that separates the lumen contents of your intestines with the other side, the tissues of your body, right? And that's when you get what we call an infection. Right? So what would happen if we didn't have an immune system? So here, just think about this, for example, on an old piece of bread that you leave out, right? You leave some old bread out and eventually it starts getting fuzzy, right? You start getting mold on it. Right? Now, where did this mold come from? Chances are it came because there are mold spores floating around in the air. And by chance, some of those spores landed on the bread, and the spores liked what they found as far as whatever capacity a spore is able to like something, right? It's a favorable environment in which the spore can germinate, grow, and start propagating. So here's a typical bread mold, right? Fungus. Um, and so what does the bread provide to the mold? The bread provides nutrients, it provides water, it provides a favorable pH environment, it provides structural support so that this fungus can grow, and provides some extent of physical protection. That's why we say if the bread provides these things, then it's a favorable environment for the mold to start growing. I want you to consider this, right? The bread is the host. The mold is an opportunistic invader. It's not like the mold actually was somewhere floating around sniffing out for the bread and actually sensed that there was bread there, right? No, the mold just fell on there and it's an opportunist. It's the right spot for it, so it starts to grow. Okay. So the moldy bread then eventually gets destroyed, right? If you leave that bread there, maybe a couple months later, you come back and it looks like this. And if you actually picked it up and broke it apart, you'd realize, wait a minute, there's actually no more bread here. This whole thing is just like a big cake of dried moldy sponge, right? That's because the mold used up all the bread. So you think, wow, that's kind of harsh. It's like the mold is very mean to the bread, right? No, that's not how you should think about it, right? Because microbes don't have any kind of malicious intent to harm their host. Harming their host is actually detrimental in many ways to the microbe being able to have success in making use of as many resources as they can. These microbes, they just simply carry out their genetic program of survival and reproduction as long as the host's resources support this. Unfortunately, damage to the host from having the microbes continuously thrive and use the resources, that's just a consequence of the microbe doing what it's programmed to do. So without an immune system to fight back, the moldy bread, right, doesn't stand a chance. Okay. I want you to think about our bodies then as an environment, as the host for microbes. Our body's tissues represent many of the same resources, It provides nutrients, water, protection. It's a favorable pH, structural support. Right now, as you're sitting there, kind of breathing normally, watching this video, you are breathing in things like mold spores. That same mold spore that would fall on a piece of bread that's on the desk or on the table next to you, you're just as likely to breathe it in. We typically are surrounded by about 5,000 mold spores per cubic meter of air. And we breathe about 2.1 cubic meters of air per hour. So therefore, if you do the math, that means by the end of this, roughly 1 hour lecture, you will have breathed in over 10,000 of these mold spores, right? And they're now in your lungs. So if we didn't have an immune system to deal with that, what would happen to us? Okay? We rely upon barriers to keep things out of our body. So this concept then is very important. When we talk about things being outside of our body versus inside of our body, right? I mean, we all have kind of a intuitive notion about things being outside versus inside. I mean, ever since you were a little kid, you knew that, your parents are trying to get you to eat the food, right? So the food on your spoon is outside, but then when you eat it, now it's inside. That's how I think we always intuitively think of outside versus inside. But I want you to set that notion aside, because when we are immunologists, we have to think about the terms outside and inside a bit differently. Okay, what is inside versus outside? It's an important distinction if any of our discussion of immunology is going to make sense to you. Think about this, right? Here's a picture of some tunnels. This is the tunnels on the Pali that I drive through every day when I commute from Kailua to Manoa and then back home again, right? When I was a little kid, I used to love riding through tunnels because I'd think, whoa, we're inside the mountain, right? But when your car goes through the tunnel, are you really inside the mountain? No, right? You are passing through the mountain, but technically speaking, you're not really inside, right? Cars pass through without contacting the dirt and rocks that make up the mountain because there is a concrete barrier, right? The tunnel. Right? If you were, for example, to actually crash into the side of the mountain and then a landslide buried your car, then maybe you'd say you're inside the mountain, right? But typically, when we're passing through a tunnel, we are still outside of the mountain. We are just passing through. So this is an important notion. Commensal microbes in our gut, likewise, should not enter the surrounding tissues. We have physical barriers that allow them to function and thrive within the spaces that we mean them to inside the lumen of our gut. So they are allowed in many ways to just kind of pass through our body, just like the food itself that you eat, right, passes through your body, but along the way, as it's digested, certain components of it can be absorbed and become inside your body. So think about this. Commensal microbes, like the good bacteria, actually become bad and pathogenic if they break through and enter the tissues of our body. Because if there's a breach, like a little cut, for example, in your intestinal wall, and the good E. coli, the good commensal E. coli that's normally helping you, makes its way through that breach and actually gets into your tissues, that bacteria is not going to suddenly go, oh, wait a minute, I'm not supposed to be here. I better get back into the lumen of the gut. No, it's not going to do that, right? The bacteria is going to encounter, wow, right? This is new. There's all these wonderful resources here in the body's tissues. Boy, I'm going to really take off now and start multiplying, right? Therefore, the good bacteria has become pathogenic just by virtue of the fact that it's breached the barriers that are meant to keep it where it's supposed to be. And now, once any microbes breach the barriers of our body and actually get into our tissues, we say that is the moment that we are experiencing infection. Okay. So here are just some other examples of physical barriers that separate the body from our external environment. Right. So in this illustration here, the blue and the red borders are the boundaries that really define inside versus outside. So obviously the blue being our outer skin, right? It's easy to imagine that the things surrounding you are outside of your skin and therefore outside of your body, but maybe it's not as obvious for you to think about the fact that the lining of all the different tracts that run through our body, for example, our respiratory tract, our urogenital tract, our gut, right, which is our GI tract, all of these that are shown with this red lining here, right, also are barriers between inside and outside. All right. And so just like the tunnel with the cars driving through the mountains on the Pali, right, those cars never go into the mountain, they just pass through. Think about all the things that you breathe in, right, or you eat. They're also just passing through without being technically inside of your body's tissues. And this is, for example, the air inside of your lungs is technically outside of your body. The urine in your bladder, the moment your kidneys actually successfully secrete and produce urine, and the urine flows from the kidneys through the ureters, it is already technically outside of your body, right? And that urine is then stored in your bladder before you have an opportunity to actually expel that urine, right? Microbes in your intestines, like we've been saying, are technically outside of our body. And this is a very important concept for understanding infection, right? Because infection has to do with the moment that microbes actually get into your body's tissues. So when you have physical barriers that are breached, for example, cuts, scrapes, wounds that allow entry into your skin, or even things like, repeated touching of your eyes, picking your nose or your mouth, right? Things like that help pathogens breach these surfaces. For example, right, you rub your eyes a lot, you're really rubbing in a lot of the microbes that you have on your fingers or that have been sort of collecting on your face, right? If you're eating, let's say we've all done this before, you're eating a bag of Doritos, those little triangular Doritos, and there's one Dorito that gets jammed up against the roof of your mouth, and you're like, ow, right? Because like it poked the roof of your mouth, and you're like, oh, with your tongue, you can kind of taste, oh, I'm bleeding a little bit up there, right? Guess what, right? That's a breach. The microbes, thousands of them in your mouth, now can get into your tissues, right? The moment that happens, you are experiencing an infection. Also, things like breathing polluted air, eating contaminated food, or exposure to sick people all increase the risk of microbial activity, right? So this is another definition then. When we say you're experiencing an infection, right, what does that really mean? I think, again, most of us just have this kind of generalized feeling of an infection. That means, oh, I got a cut, and then 2 days later, it started getting sort of puffy and, a little bit warm and tender. Oh, it's infected, right? So 2 days later, I'm experiencing an infection. No, technically speaking, that infection happened the moment you got the cut and microbes began to go into your tissues, right? What happens next, whether or not your immune system can successfully beat that infection so that you never even experience anything more, and by the end of the day, you even forgot that you got a cut, or if 2 days later it does starting to get inflamed, right? Both are just simply responses to that initial infection, right? The vast majority of infections remain highly localized. For example, a paper cut or cutting the roof of your mouth with a Dorito, and you don't even worry about it because within a few days, there's no even more evidence that there was an infection that happened, and you don't even sense that you've gotten sick at all, right? So that's good because every single day we are experiencing, right, a multitude of infections that we don't even think about. A paper cut, or you get a splinter, right? Or even when you're brushing your teeth and you're trying to like talk on the phone at the same time, you're distracting, you jam your toothbrush against your gums and you're like, ow, right? That's an infection. But we don't worry about those things because our immune system is very good at taking care of those infections before they actually become anything worth worrying about. So this implies that we must have an on-call, ready-to-act way of detecting and neutralizing pathogens that have entered the insides of our body very quickly, right? So our bodies must be ready for diverse pathogens because we are surrounded by all kinds of pathogens every day. Exposure to pathogens is a normal part of our daily life. We are literally surrounded by them. Some pathogens are common everyday ones, right? Like the pathogens that you have around your house or in your car. You're exposed to those all the time, right? Other pathogens, though, might be more, for lack of a better word, exotic or rare. They are uncommon ones that may be new to your body. Your body has never seen them before, or even new to the entire human species. Right? So your immune system has to be able to deal with both types of scenarios, common everyday pathogens that you see over and over and over again, as well as the rare ones that come once in a lifetime that your body never has seen before, or maybe even possibly the whole human species has never seen before. You have to be able to deal with them. So how do we deal with familiar versus unexpected infections from pathogens, right? So our bodies must have two cooperating systems here. One is that broad general response. That's the ready to act, the one that's on call all the time to respond quickly. And it must also have a more focused special response that's reserved for those exotic, uncommon pathogenic infections. Right? So these are the two main branches of our immune system, the general response and the special response. And as we learn more about it in the next couple lectures, we will give these more technical terms. But for now, we can say that immunology really is the study of how these two sides of our immune system work together to keep us alive. So I started this lecture kind of musing about the fact that this morning, chances are when all of you woke up, you probably weren't thinking about your immune system. You're more concerned about things like how your first week of classes would work. Maybe could you get your financial aid stuff sorted out? Could you get the textbooks that you need? Things like that, right? You didn't think about your immune system, but the important thing is your immune system has been a vital part of every moment since you woke up this morning, and in fact, ever since you were born, right? If your immune system this morning had magically stopped working entirely, what would happen? Right? I think at first you wouldn't notice any difference because after all, your immune system is just meant to protect you against pathogens, right? In fact, maybe even after one day, you wouldn't notice anything happened. But the point that I want to impress with you is that if your immune system actually stopped working entirely this morning, right, by the time we get to the end of the week, you would not be worried about financial aid or your classes, because if your immune system wasn't working anymore all week, by Friday, you would be dead. So if that thought kind of horrifies you, but at the same time kind of intrigues you, right, to get you to realize that your immune system is always working and the important role that it actually provides in keeping you alive, then this is the right class for you, because over the course of the semester, we will talk about all of these things. All right, so for now, let's call that our first lecture. Go ahead, make sure you go on La Lima and get the syllabus and schedule downloaded. Okay, and then on Wednesday, I will talk more about the first quiz. There is no quiz due this first week, okay, but I will talk more about the quiz on Wednesday. All right.